If you build a search bar that fires an API call on every keystroke, you're hammering your own backend for no reason. A user types laptop. That's 6 database queries when you only needed 1. Multiply that by thousands of users and you've got real performance problems and a real cost. In this video, I'll show you the 2 techniques that fix this: debouncing and throttling. When to use each, the one mistake that quietly breaks both ways, and how to build them from scratch in pure JavaScript. This stuff shows up constantly in production and in technical interviews, so it's worth getting right. The core concept. There are 2 ways to control how often a function runs. Throttle says, run this at most once every X milliseconds, no matter how many times it's triggered. The function fires on a steady drumbeat while the activity is happening. Debounce says, wait until the activity stops for X milliseconds, then run once. If the activity keeps going, the wait keeps resetting. The easiest way to remember it: debounce waits, throttle controls. Debounce waits for silence, throttle controls the rate. So which one for a search bar? Debounce. We don't care about every keystroke. We only care once the user pauses. We'll wait 300 milliseconds of silence, then hit the API once. Throttle is the wrong tool here, and I'll show you why later. Building debounce. Here's the implementation. It's small, but every line matters. Function debounce, callback delay. Let timeout ID. Return function spread args. A new event came in, canceled the timer that was waiting. Clear timeout, timeout ID. Start a fresh timer. Timeout ID equals setTimeout, callback, callback.apply, this spread args, delay. We return a wrapper function that holds timeout ID in a closure. That's the key. That variable persists between calls, so each invocation can see and cancel the previous timer. Every time the event fires, we immediately clear timeout to kill the pending timer, then start a brand new setTimeout. The callback actually only runs if a timer survives the full delay without being interrupted.
As long as the user keeps typing, we keep resetting, and nothing fires. 2 details worth calling out. We use apply with this, and spread args, so the original this context and arguments pass through untouched. That matters if your callback relies on either. Now let's use it on a real input. Function search, console.log, searching for query. Const debounced search equals debounce search 300. Document.querySelector, search.addEventListener, input, event, debounced search, event.target.value. The search runs only after the user stops typing for 300 milliseconds. Quick note on testing this. If you call it 3 times in a row in your console, debounced search L, debounced search law, debounced search lap, only 1 call runs. But not because debounce picked the last word. Those 3 lines execute in the same instant, so the first 2 timers get cleared before they ever fire, and only the last one survives. In a real input, keystrokes are spaced out over time, and the timer resets on each one until you pause. That's the behavior that actually saves your backend. Building throttle. Throttle is a different shape. Instead of resetting a timer, we put up a closed sign for a fixed window. Function throttle, callback, delay, let should wait equals false. Return function args. If should wait, return. Callback.apply, this args. Should wait equals true. Set timeout, should wait equals false, delay.
The first call runs immediately and flips should wait to true. Any calls during the window are ignored. After the delay, we reopen the gate. So no matter how many times the event fires, the function runs at most once per interval. This is perfect for scroll, resize, and mouse move, events that fire continuously and where you want regular updates, just not hundreds per second. Function handle scroll, console.log, scroll position, window.yscroll. Const throttled scroll equals throttle handle scroll 300. Window.addEventListener, scroll, throttled scroll.
Now, even if scroll fires 100 times a second, your handler runs at most once per 300 milliseconds. When to use which? Here's the rule. Reach for debounce when you only care about the final state after activity stops. Search inputs, form validation, autosave, checking if a username is taken. Reach for throttle when you want steady updates during continuous activity. Scroll position, infinite scroll triggers, resize handling, drag and drop, tracking mouse movement. Search bar, debounce. Scroll tracker, throttle. Get those two backwards and your app feels broken. The mistake that breaks everything. This is the bug I see most often, and it's sneaky because the code looks right. Debounced function created inside the handler. Search input.add event listener, input, event. Const debounced search equals debounce, search 300. Debounce search, event.target.value. Every keystroke creates a brand new debounced function with a brand new timeout ID. Since each one has its own fresh timer, there's nothing to cancel. Every call fires after its delay, and you're right back to spamming the API. The debounce does literally nothing. The fix is to create the debounced function once, outside the handler, so all the events share the same closure and the same timer. Correct. Created once, reused for every event. Const debounced search equals debounce, search 300. Search input.add event listener, input, event, debounce search, event.target.value. Same logic applies to throttle. Create it once. If you take one thing from this video, make it this.
What we built is the clean, educational version, and it works. But production libraries add options you'll eventually want. Leading runs the function immediately on the first call. Trailing runs it at the end after the delay. That's the default in what we built. You can have one, the other, or both. There's also cancel to scrap a pending call, and flush to fire it right now. In a real codebase, most people reach for Lodash's debounce and throttle. They're battle-tested and handle all these edge cases. But building your own, like we just did, is the best way to actually understand what's happening under the hood. And it's exactly what an interviewer wants to see you do on a whiteboard. Quick recap. Debounce waits until activity stops, then runs once. Throttle runs at most once per interval during activity. Use debounce for search, validation, and autosave. Use throttle for scroll, resize, and mouse move. Create the wrapper once, outside your handler, never inside it. And the one line that locks it in, debounce waits, throttle controls. If this cleared things up, a like genuinely helps the channel. And let me know in the comments which one tripped you up first.